Hello, quick video today. We're kind of doing a lot of the same doing before. It's just going to be you creating the graph, and instead of doing like multiple choice questions, we're going to be doing all worksheets next week. So this is kind of a primer. If you can figure out the best way for you to upload the worksheet. I'm allowing a whole bunch of different things because I understand not everybody has a printer. Like I haven't had a printer for a lot of my home life, so I had to print at school most of the time. The different ways are if you print it, great. That's pretty convenient for you. You can scan it if you have a scanner, or you can take a picture with your phone or with something else, but probably with your phone. And either of those you can upload to the upload space we have. Otherwise, you can edit it on your computer, and so that's a lot of what I would do. So I'd use like I don't know, Paint or the touch screen or something like that to like draw in the curves and answer the questions, and that would be fine. You can use like PDF editor or anything like that. If it's easier to do that than print, that's cool. Last thing you can do is uh, if you can't print or you don't feel comfortable editing it, you can also um, do the alternative where you just do it on a separate sheet of paper. Separate sheet. And that is also totally legit. So even though this is a worksheet, if you just give me like a picture, and so this would also be like a picture or scan, so similar to this process. If you just give me some sort of like something in notebook paper where you go through all the questions or on graph paper or something like that, that's also totally acceptable as far as how to turn these in. So this process here, like where I allow a whole bunch of different mediums, is going to be true next week too when we do more parent graphy stuff. Although if you can find a way to do printing or editing, you will save yourself some effort, but you can totally do it on a separate sheet of paper, any of these assignments. Anyways, to talk about some actual math today, really it's a lot of the same stuff, so it should feel very similar to to the last assignment we did. We're still using the exact same equation, which is this equation, the square root equation. And the only things we're really adding today is making you graph it and then find all the x, y intercept, all that kind of stuff. So I was just going to run through a couple examples that I was going to do on here. One hint, you can do you can check your work on all of these at Desmos.com. If you just type in the graph into Desmos, you can figure out where it is and then graph it. So that's pretty cool. If you want to do this without Desmos, well, we just take an equation. So y equals the square root of x plus 3 minus 4. We say, okay, our h is, because there's a negative in the equation and this is a positive, our h is negative 3. Our k is negative 4. What h comma k is, negative 3 comma negative 4, is the point at which our square root function starts. So if I went to graph this, I'd go to negative 3, negative 4, and then I'd go over 1, up 1, and then staying with the square root idea, when since the square root of 4 is 2, I'd go over 4, up 2. So from my starting position, negative 3, negative 4, I went over 4 from negative 3 to 1, and then up 2. And this creates the slowly increasing graph for this square root function. So the general rule is from your starting position, over 1, up 1, and then over 4, up 2. And then if you wanted the next point, that's easy. It's like over 9, up 3. And it's just the square roots that we know that are used for this. So, I was going to do one more example of this style. So now we're going to take this equation, y equals the square root of x plus, or let's do minus this time, x minus 4 plus 6. Ooh. So here, because it's x minus h in the equation, 4 is going to be my h, 6 is going to be my k. So 4 comma 6 is my starting point for my quadratic. And so we go to 4 comma 6, put a dot, and then same rule, over 1 up 1, doop doop, over 4 up 2, and you create a square root graph going up like so. This is the kind of thing that's going to be asked of you on the homework, except it goes a little further. So I graphed a couple of these, but what I haven't done is found the domain, the range, the x-intercept, and the y-intercept. So the cool thing about this one is, since it starts here at 4, 6, and then goes up and over forever, there's no x-intercept, and there's no y-intercept. The range is the y values. We start at 4 and go up, so y is greater than or equal to 4. The domain is our x values. Our x values, oh, did I goof? Yeah. The y values start at 6, because my y value is 6. Oopsies. Y is greater than or equal to 6. And domain, x is greater than or equal to 4, because we're going up forever. It's also fine to write either of those as 4 is less than or equal to x is less than infinity, or 6 is less than or equal to y is less than infinity. You just don't need this less than infinity stuff if you don't want to write it. So that's domain, range, x-intercept, and y-intercept. Now I want to pop in and take a peek at the homework. So the homework is this worksheet. I actually snagged this off my homework calendar to put it on this computer. And it's going to ask you to write a couple equations. It's going to ask you to graph 4 different equations here, and then write the domain, range, x-intercept, and y-intercept. So those are the things that are going to be asked of you. Now, one really quick hint. We didn't talk about reflections. I talked about these during my live stream, so if you catch that, I talked about them there, but I'm happy to talk about them here. I'm going to take one that's double reflected. So here's how you make here's how you reflect square root functions. Here's a boring square root function. A boring square root function looks like this. If you reflect it over the x-axis, it would be down here, going down instead of going up. And the equation of that dotted line would just be y equals the negative square root of x. So a negative on the outside, not next to the x, but next to the square root, flips over the x-axis. If you want to flip over the y-axis, which means we're going this way, so how do I make this one look different? I guess I put some dots on this line or something, then it's like labeled different. Moral of the story is this guy's equation would be y equals the square root of negative x. So if the negative is on the inside next to the x, we reflected over the y-axis. And this is going to be a really consistent rule. If the negative's on the outside of even something like an exponential or a quadratic, negative on the outside means reflection over the x-axis. And if the negative is on the inside, like y equals 2 to the negative x, or y equals negative x to the second power, like this, that's a reflection over the y-axis. So next to the x over the y-axis, on the outside over the x-axis is our general reflection rule. So I'm going to do one more and bring it home. I'm going to throw a reflection in here. This should be harder than anything on that worksheet too, because of the reflection here. I'm going to do all the things for this. So I'm going to find domain, range, x-intercept, y-intercept, and I'm going to graph it. So first thing, h comma k is the opposite of this, -1, comma 2. Sweet. Found the starting point. Now, this other thing says I'm reflecting over y. So what reflecting over y means is instead of being an up square root like this, I'm a because I'm or did I goof that? No. Sorry, reflect over x is what I want. So instead of being an up square root like that, I'm a down square root. Negative on the outside. Reflect over the x-axis. So cool. I'm a down square root. I start at -1, comma 2. -1, 2. Boom. Because I'm a down square root, I'm going over 1, down 1, over 4, down 2. So over here to 3. And now I just draw a down square root like this. Something like that. And ideally, yours would look better than mine and would start getting lesser and lesser with its slope thingy there. Mine was a little bit, it's still really ugly. Feels bad. Anyways, moving on to domain, range, x-intercept, and y-intercept. I'm going to solve all of these. First of all, x-intercept and y-intercept are pretty easy because I put dots at them. 0, comma 1 is my y-intercept. My x-intercept is 3, comma 0. So that's where I went through that. When I went down 4 over 2, over 4 down 2, blah. I ended up over 4 is 3 from -1, down 2 is 0. So sure enough, 3, comma 0 is the points. Domain is always x, and our x's go to the right, so they always get bigger than or equal to where we start, which is at -1. For my range, because it's going down, y is going to be less than or equal to whatever my starting point is, because that's my highest point. And my starting point is 2. And that's everything. That's domain, range, x-intercept, and y-intercept. So that is what is going to be asked of you today on this assignment. And you should be able to do all of these, hopefully with that help. Just please remember, if you're struggling with any of these, let's not do calculus. Just type them in here, like go to Desmos, and if we type in, let's do square root of x minus 2, boom, graph. And you want to figure out where its intercepts are, just click on the, 2, comma 0, that's its x-intercept. Y-intercept, none. And so you can use graphing tools to help you with this assignment. And I encourage you to do so, because you can check all your answers pretty easily. Alrighty, that's it for today. I'll see you next week. Our next video is probably going to be a little bit long because we're doing parent graphs next week, and there's a fair amount to talk about. So I apologize that it's probably going to be like a 15-20 minute video. But see you then.